so today we are going to cover section 8. It is on spheres. In this lesson, we're going to cover both surface area and volume. So our first slide here is telling us what a sphere is, and it's the set of all points in space equidistant from a given point. And that given point there, that could be the center. What we're going to need to calculate our volume and our surface area of our spheres is just a radius. That would be the only thing that's going to be given to you. If you're given a diameter, know to divide it by 2. So a sphere looks like a basketball or a globe. So it's going to be like a round shape. Yes? Yes. Okay, now in the picture down here, this is where we were talking about if we took a plane or something and sliced it, and then if we picked up the half, that circle that's created is called the great circle. Know if you were to slice that sphere right down the middle, and if you think about like the earth or a globe, that line could be the equator. And then it would divide it into 2 hemispheres. And we can see that, when we talk about geography, you got your northern and your southern hemisphere. The next one has the formula for the surface area of the sphere. And that is going to be 4 times pi times the radius squared, where r is the radius of our sphere. So it's one solid surface. It's not going to be like a separate triangle or a separate rectangle. It's one solid surface. And it's represented by 4 times pi times the radius squared. The next slide has the volume of a sphere. And that formula is represented by 4/3 pi times the radius cubed. Again, where r represents the radius of the sphere. We got this table to fill in. So what we're going to do is we're going to fill it in horizontally. So we're going to fill in when we're given, like for number 1, they're giving us the diameter. They want us to find the radius and also find the surface area and the volume. Now, what we could do is we can go ahead and write the formulas up here. So for the volume and the area, for the area formula, I'm going to be using 4 times pi times radius squared. But for the volume column, I'm going to use 4/3 pi times radius to the 3rd power. All of our answers here for the area are going to be units squared, and over here will be units to the 3rd power, or units cubed. What do you need to do to it, Bella? Divide it by 2. So for the radius here, it's going to be 6. Okay, now I'm going to go ahead and fill in, and I'm going to try to write everything here in the little square. So I'm going to use the formula I wrote up in yellow. So I know my surface area is represented by 4 times pi times radius squared, so 6 squared. And I'm going to leave this in terms of pi. So I'm going to end up doing 4 times pi times 6 squared is 36. And 4 times 36 is 144 pi units squared. Then for the volume, again, I'm going to use the formula up here in the corner that I wrote in yellow. So volume is going to be 4/3 times pi times my radius to the 3rd power. So I'm going to go ahead and multiply all that out. So 6 to the 3rd power, 6 times 6 is 36, times 6 again gives me 343. Now, does everybody know your divisibility rule to see if something's divisible by 3? How to do that? Okay, where you take the digits of the number and you add them. So if I add 3 plus 4 plus 3, I get 10. Can I divide 10 by 3? No. So I know I can't divide 343 evenly because the 10 doesn't divide evenly by 3. So what I'm going to have to do here then is, because I can't simplify anything, I'm going to multiply 4 times 343, and then I'm just going to leave it over 3. So when I multiply 343 by 4, I get 1,372 over 3 pi units cubed.
Can we check if that's divisible by 3 by adding it together?
Okay, we can try it. So if we did that, generally if it's not going to be divisible by either of the two numbers you multiplied, it won't, but we should double check it. So if I do 1 plus 3 plus 7 plus 2, I get 13, and 13 can't be divided by 3, so I know it's simplified. Does that make sense? So that would be your final answer for this box. That would be the volume. All right, I want you guys to try to fill in the second row. See what you can do, and then we're going to check our answers. All right, let me go back. I wrote the wrong information on here. This should actually be 216. And if we do our divisibility check, 2 plus 1 plus 6 is 9. So 3 can go into 9, so 3 can go into 216. It actually goes 72 times. So actually this is the answer for part 2. Let me fix that. So then 4 times 72, because this is now a 1, 4 times 72 is actually 288 pi. Good catch, thank you. So 288 pi units cubed. That 1,372 is the answer for the next one. All right, let me go ahead and do it. So I'm going to turn my radius into a diameter by multiplying it by 2. And now I'm going to plug in 7 into my radius for my area formula. So I'm going to do 4 times pi times 7 squared. So 4 times pi times 49. And 49 times 4 gives me 196 pi units squared. I'm going to repeat the process for the volume, but I'm going to use the other formula. So for volume, it's 4 over 3 times pi times 7 cubed, and 7 cubed is the 343. 4 over 3 times pi. I saw before that I could not simplify that. So 4 times 343 gives me the 1,372 over 3 pi units to the third power. The next one, for number 3, I don't have a radius value, so I need to work backwards here. So what I'm going to do here is I'm going to set this equal to my volume formula, which is 4 over 3 pi times radius to the third power. So now I need to start trying to isolate the r. And I can do more than one way. First thing I'm going to do is get rid of the fraction. So I'm actually going to multiply both sides by 3. So that's going to get rid of my fractions. So now I have 32,000 pi is equal to 4 pi times radius to the third power. Now, this next step, you can either choose to do it in one step or two. I'm actually going to divide it by 4 pi altogether. You could have done pi first and then 4 second. I'm just going to do it just to save some room here. So now I have my radius to the third power isolated, and now I'm going to divide 32,000 by 4, and I get 8,000. Now at this point, I need to find basically the cubed root of 8,000. So I'm going to do a factor tree here to see, because if I wasn't using a calculator, I could do the tree and figure out when I have 3 of something. So I could break this into 8 times 1,000, break this into 2 times 4, and then 2 times 2. Here I could do 10 times 100, and then 10 times 10 times 10. Notice I have 3 here and 3 here. So the cubed root of 8,000 is 20. So my radius here is going to be 20. So now to turn it back into a diameter, I'll just times that by 2, and my diameter is 40. Now that I have a radius, now I can do my surface area formula a lot simpler. I'll just do 4 times pi times 20 squared. 4 times pi times 400 gives me 1,600 pi units squared. No, that's kind of tight there. So 1,600 pi units squared. Is the surface area. Next, we have 12 pi as our surface area. Again, we're going to set it up the same way. We're going to go ahead and set this equal to the formula, which is 4 pi times radius squared. So let me do the work maybe away from it. So my equation will be 12 pi is equal to 4 pi radius squared. I'm going to actually divide in one step. You could do it in 2. I'm going to divide both sides by 4 pi. Pi's cancel. 12 divided by 4 is 3. That's equal to r squared. If I wasn't using a calculator, I'm just going to leave it as radical 3. So that is my radius, the square root of 3. Remember to turn it into a diameter, times it by 2. So the diameter becomes 2 radical 3. And now to calculate the volume, I am going to take the square root of 3 and plug it in. So 4 over 3 pi times square root of 3 cubed. So if I do square root 3 times square root 3, oops, too many square roots here, times square root 3, this just becomes a 3, and this one didn't have anything to pair it up with, so it becomes 3 radical 3. So now I have 4 over 3 pi times 3 radical 3. I could simplify my 3's, so then my final answer here is going to be 4 radical 3 pi, or if you want to put the pi in between there, that's fine, but usually pi will go after the number. So that is going to be, let's see, what did I do here? So units to the third power. So that goes in here, 4 square root 3 pi units to the third. Okay, next one, this time they're not giving me like a number for my radius. So basically we're just gonna almost write the formula. So for this one, to turn a radius into a diameter, times it by 2. And then for the surface area, basically I'm just gonna fill in my formula. So 4 pi, and then my radius is r, so r squared. Same thing here, just rewrite the formula. 4 over 3 pi radius cubed. And again, remember this is units cubed. So 3, and then units squared. Then for this one, we're going to double it, make it 4r. And then over here, I'm going to plug it in. So 4 pi, and I'm going to square 2r. So this actually turns into 2r times 2r, which is 4r squared. And then the 4 pi. And now I'm going to multiply the 4's. So my final surface area here is 16 pi radius squared units squared. Yes?
After we multiply the 2r by 2r again, why do we still leave the square?
Because the square is on the r. So the square, so like when I'm squaring 2r, what I'm doing here is multiplying 2r times 2r. And remember, when you multiply variables, you add their exponents. So the r becomes r squared, but I multiplied the 2 times 2, and that's how I got 4r squared. So the exponent actually distributes to both the 2 and the r. Yes, question?
For the one above with the 32,000,
Yes.
how do you get rid of the r cubed? Like, how do you get rid of the cube?
Okay, so what I did was your cubed root, I had to cube root the 8,000. So what I ended up doing was a factor tree here. If you're using a calculator, you could find the cubed root, but if you weren't, you're gonna have to break it down, and then once you get it, you know, like into prime numbers or something where you could recognize that you have 3 of, remember the cubed root is what number times itself 3 times. So 8 was 2 times 2 times 2, and then the 1,000 was 10 times 10 times 10. So then out of this would come out a 2, and out of this would come out a 10, and 2 times 10 is 20, which is my radius. But if you were using a calculator, a lot of the calculators have a cube root on it. Otherwise, you got to do a factor tree and do it by hand. Okay, then the last one is the volume, using a 2r as the radius. So 4 over 3 pi times 2r cubed. So this one I'm going to do 2r times 2r times 2r, which gives me 8r cubed. So now I have 4 over 3 pi and then 8r cubed. I can't simplify the 8 and the 3, so I'm going to make it 32 over 3 pi r cubed units cubed for my volume. Now, you could also write it as 32 r cubed pi over 3. Either way, if you're putting pi last. So that would be when you don't have like a number. We're just going to plug it in. All right. Next on part 7 here, I guess it said compare the areas between 5 and 6. So 5 and 6, they're asking us to compare those areas that we got when we did 5 and 6. So for 5, let's see what we got here. So 5, we got pi r squared. And for the volume, for number 6, the area was 16 pi r squared. So if we compare them, we can see that it looks like it's either going to be the first figure squared or times by 4. Then if we compare the volumes, the volume of 5 was 4 over 3 pi r cubed. And then for number 6, it was going to be 32 over 3 pi r cubed. And this one looks like it was multiplied by 8. The purpose of this was to lead us into the similar figures, which we're going to do in the next lesson. to show the relationship. And again, remember when you have similar figures, you've got one small one and one large one, or one large one, one small one. It's like a dilation, you know, to compare them. Everybody good on that example? All right, that was a lot of work. Let's try the next one. Okay, here it says the number of square centimeters in the area of a sphere is the same as the number of cubic centimeters in the volume of a sphere. Find the radius of the sphere. So it's basically telling us that surface area is equal to volume. So because I don't know what the radius is, I am going to set my two equations equal to each other. So again, the surface area, let me do this. I guess you can see it. Let me do it in yellow. Maybe that'll show up better. 4 pi r squared is for surface area. And for the volume, I'm going to do 4 over 3 pi times radius cubed. I now have to get r by itself, so I'm going to start moving things away. First thing I'm going to do is get rid of my fraction. So I'm going to multiply both sides by 3. I end up with 12 pi r squared. Over here, the 3's cancel. Next, I'm going to divide by pi. Or actually, I could divide by 4 pi. I could do it all in one step. If you'd rather do it individually, that's fine. So then this becomes 3r squared equals r cubed. Now I have to still try to get r by itself. So I'm going to divide both sides by r squared. Remember, when you divide exponents or variables with exponents, you subtract them. So my radius is equal to 3. So when the radius equals 3, my surface area and my volume will be the same. It says a solid consists of a hemisphere of radius 1 meter on top of a cone with the same radius and height with 5 meters. Find the volume of the solid. So I'm going to basically look like what I'm going to draw is an ice cream cone. Let me do yellow again so it shows up. So here is the hemisphere. Here is my cone. It says my hemisphere has a radius of 1. So this has 1 meter. And it says that the cone has a height of 5. So I'm going to be doing two formulas here. I'm going to be finding the volume of the sphere and then divide it by 2 because it's a hemisphere. So 4 over 3 pi times radius cubed. And then when I'm all done with that, I'm going to divide it by 2. Then I'm going to add it to the volume of my cone, which is going to be 1/3 pi times radius times height. And this is what was on your quiz. Remember, it's 1/3 capital BH. So let's start plugging in our values. So I have 4 over 3 times pi times 1 to the 3rd power. Still have divide by 2 here. Then I have 1/3 pi times 1 squared times 5. So over here, I'm going to simplify this. The top part, 1 to the 3rd power is just 1. So I have 4 over 3 pi over 2. Over here, I can simplify this. 1 squared is 1. So this becomes 5 over 3 pi. I still have to simplify this. So it's divide by 2, which is really like multiplying by 1/2. Still have the 5 over 3 pi. When I multiply that, I could simplify here and get 2/3 pi plus 5/3 pi. So the total volume is going to be 7 over 3 pi unit, or meters it was. Meters to the 3rd power, or meters cubed. So that would be the volume of my ice cream cone here, or my complex figure. Okay, so today we got to see volume and surface area of the figure. So your homework tonight is practice B, and then tomorrow we will cover 11.9.